A Category 5 cyclone is a high-performance system. These massive spirals of cloud and wind act as the visible exhaust for a planetary machine running at maximum capacity. The fuel for this machine is constant. Every square meter of Earth's upper atmosphere is hit by 1,361 watts of solar radiation every second. This energy hits the planet unevenly. Because of Earth's tilt, the equator absorbs a massive surplus of heat, while the poles sit in a deficit. Without a way to move this energy, the tropical oceans would boil away, while the polar regions locked into a permanent, expanding deep freeze. We avoid that extreme because Earth functions as a unified system. This image shows the result, a continuous network of swirling air and water that links the scorching tropics to the frozen poles. Weather is the mechanical output of this interaction. Its primary function is to redistribute solar energy and maintain a global thermal balance that allows life to exist. The engine's work cycle begins at the edge of the atmosphere, where incoming shortwave solar radiation first arrives. Not all of this energy enters the system. Bright surfaces like clouds and ice reflect about 30% of it directly back into space. This reflective capacity is known as albedo. The remaining energy reaches the surface and is absorbed. But it doesn't stay there. The ground and oceans re-emit that energy upward as long-wave infrared radiation. This process happens almost entirely within the troposphere, the densest layer of our atmosphere, extending just 12 kilometers up. Here, the trap is set. Trace gases intercept the outgoing infrared heat and re-radiate it back towards the surface. This is the natural greenhouse effect. By pinning this heat against the surface, the atmosphere creates a localized reservoir of thermal energy, the high-octane fuel that drives all atmospheric motion. This heat moves into the air through conduction, as the surface warming the gas molecules directly touching it. This creates convection. Warm, less dense air rises rapidly, while cooler, heavier air sinks to replace it. This vertical motion changes the weight of the air pressing on the ground. Rising air creates zones of low pressure, while sinking air creates zones of high pressure. We use lines called isobars to map these differences. Wind is the physical manifestation of air rushing from a high-pressure zone to fill a low-pressure void. In short, wind is the atmosphere's physical effort to equalize the pressure imbalances caused by trapped heat. Water vapor serves as the primary fluid driving this engine. As warm updrafts rise from the hydrosphere, they lift millions of tons of invisible moisture into the atmosphere. As this air climbs into lower pressure environments, it expands. This adiabatic expansion causes the air temperature to drop instantly. When the temperature hits the dew point, the air can no longer hold the vapor, triggering immediate condensation. The results are the clouds we see every day, from wispy cirrus streaks at 6 kilometers high to towering cumulonimbus clouds that fuel massive thunderstorms. On the larger scale, these movements create collisions between massive air masses. A cold front will slide under a warm one, forcing it upward and triggering heavy rain. When this cycle occurs over oceans warmer than 26 degrees Celsius, it spirals into a tropical cyclone. This is the most violent expression of the engine's power. These storms are the planet's most efficient method for purging excess heat from the surface and dumping it into the upper atmosphere. For millennia, the Earth system maintained a predictable thermodynamic loop, balancing the incoming solar energy with a steady mechanical output. Human activity has introduced a new variable, the burning of fossil fuels, which shifts the chemical makeup of the atmosphere. By increasing the concentration of greenhouse gases, we have created an enhanced greenhouse effect. This traps a significantly higher percentage of infrared radiation within the troposphere. Thermodynamics dictates the outcome. An engine loaded with surplus heat is forced to perform more mechanical work. We are an integral part of this system, and we must recognize that overclocking the planetary engine guarantees stronger storms and a volatile atmosphere tomorrow.